Today we're going to be talking about the derivatives of inverse functions and the derivatives of inverse trigonometry. So I need to find the derivative of the inverse of this function. Well, remember, to find the inverse, we switch x and y. And then take the derivative of each term. The derivative of x with respect to x is 1. Derivative of y cubed, that's implicit differentiation on this right side. So 3y squared dy dx. 6y dy dx minus 7 dy dx. Factor out your dy dx. And then divide. So dy dx, the derivative of my inverse, is 1 over 3y squared minus 6y minus 7. So the reason I did that is look at what the derivative of f of x is. The derivative of f of x would be 3x squared minus 6x minus 7. So it's 1 over the derivative of f of x, so it's 1 over the derivative of f of x just with y's in for your function value. Okay, but remember, y equals the inverse. So that's how we get this formula. Okay, derivatives of inverse functions. Since the slopes are reciprocals, because your original and your inverse are reflections across the line y equals x. So therefore, the derivative of the inverse at some f of a function is 1 over my original function evaluated at a. And this is that formula that I gave to us earlier. Suppose that the domain of a function at an open interval, and that is differentiable and a 1-to-1 on this interval, and I'll talk about how we can tell 1-to-1 in a minute. Then f is differentiable, we have this equation. Honestly, this one isn't used a lot on the AP test. What they use is a very similar formula, and let me derive this other formula, which is kind of the same thing. So let's let the inverse be g of x. Now we know that the composition of the original function and the inverse is equal to x. So now take the derivative of the left with respect to x. So I'm going to do d dx on the left and d dx on the right. So the derivative of the left side is a chain rule derivative of the outside function, leaving the inside alone, times by the derivative of our inside function. And then the left side is 1. So I'm looking for the derivative of the inverse. So I'm solving for this g prime of x. So g prime of x is equal to 1 over f prime of g of x. Again, where your f inverse, and so g of x is your f inverse. This is what you're going to be seeing a lot more on the AP. Is they're going to give you f is the inverse, g of x is the inverse of f of x. Okay, so if f is differentiable at every point, and your derivative is never 0, then f has an inverse, and f of x is differentiable at every point. There's also something that you need to look at. F of x equals x squared. Okay, this function is not 1-to-1. So this function is not 1-to-1 because it doesn't pass my horizontal line test. I go through 2 points whenever I draw a horizontal line. The derivative is not always positive or not always negative. So kind of the point of this slide is f of x is 1-to-1, okay, has a differentiable inverse, okay? You can only find the inverse if a function is 1-to-1. So if f of x is 1-to-1, the derivative is either all greater than 0 or your derivative is all less than 0. So let's do an example involving that. Show f of x is 1-to-1 and has a differentiable inverse. So if I show that it's 1-to-1, then I know I have a differentiable inverse. So in order to show it's 1-to-1, I take my derivative. Now, I don't know what the original f of x looks like without a calculator, but I know what my derivative looks like. The derivative of f of x is always greater than 0 on my interval. So therefore, f of x is 1-to-1 and has a differentiable inverse. And has differentiable inverse. Okay. Finding f of 1. Okay, that's easy. I just plug in 1. F prime of 1, well, we found the derivative up there, so it's 3 plus 3, which is 6. So now remember, with this point up here, I'm giving us the point of x is 1, y is 9. So now in my inverse, x's and y switch. So if my x in my inverse, which is y in my original, is 9, then I go to the x value of the original to get f inverse of 9 is equal to 1. Now here, my derivative of the inverse. Remember, derivative of the inverse, f inverse of 9 is 1, so I'm doing 1 over the derivative at 1, so that's 1/6. Okay, Mrs. Marnell, why do I care? Because we need this information to find the derivative of our inverse trigonometric functions. And I don't know why that's there. I think I was in a nutty mood when I made this a few years ago. Okay, we want to find the inverse, or we want to find the derivative of an inverse trig function. So remember, what does this mean? This means the ratio at some angle. Okay, so my angle is y. My ratio for sine is x over 1. Using your Pythagorean theorem, we can get our third side to be this. So I don't know how to find the derivative of inverse sine, but I know that rewriting this, I can say the sine of y is equal to x. The sine of angle y is equal to x over 1. So now I take my derivative. Derivative of the left side is cosine y dy dx, that implicit differentiation again. Okay, so now I look at what the cosine of y is. The cosine of y is equal to adjacent over hypotenuse. So the derivative of inverse sine is equal to 1 over x squared. And don't forget your chain rule. Sometimes you might have something in that angle. Okay, so don't forget your chain rule. So, derivative of inverse sine, I want you to know that. Derivative of inverse cosine, it's the same thing as inverse sine, just I have a negative. Kind of very similar to when we took our regular derivatives. Inverse tangent, I also want you guys to memorize. And then inverse cotangent is very similar. Honestly, we don't see secant and cosecant that often. They might show up in homework. I'm almost likely 100% sure I'm not going to put it on a test. Almost 100%, 99.99999% sure I wouldn't put these on a test because I haven't seen those show up on the AP, but you do need to know these top ones. And then remember, always take the derivative of whatever inside. Okay, derivative of y with respect to the appropriate variable. There's really not a y in there, but I'm doing the derivative of this function. We have a product rule. One function, another function. So, derivative of the first, leaving the second alone, plus leaving the first alone, derivative of our second is 1 over the square root of 1 minus whatever in my angle squared times by the derivative of 7x, which is just 7. Now simplifying that, okay, so that is our derivatives of inverse trig. Please make sure your lesson summary gets submitted, which is right below this video.